Welcome back to this last session of this conference, and I am thrilled to host David Bernstein. David is the author of a book that you may have read already, which is titled Beyond Legacy Code. So that's on point. I read that book 3 years ago, and I thought, oh my God, this is a very good, practical, and useful reference anytime. Like, all of these practices we have been talking about, they are in here, and I really like this book. And later, I went to the Legacy Code Rocks community and I found David here. And so I was really happy to be able to connect with him. And I'm really, really happy that he is here today and he will talk about unit tests, how you can use unit tests as specifications. Before that, I also need to mention that David is teaching online. So if you want to learn how to write maintainable software and do that, all of these best practices and take that into your work, or bring colleagues also to be trained here, he will do. There is a class in January. I'm gonna share the details in the chat, and he's offering a discount to people with the code Socrates. I'm going to put all the details in the chat, but basically, it's a nice gesture he made here. And without further ado, please, David, welcome, and the stage is yours.
Thank you, Nicholas, and thanks everyone. I'm really thrilled to be here. This is my community. You guys are my people, so I'm so happy. It's a little early in the morning for me, so I'm just waking up, but I couldn't miss this opportunity. And I want to talk to you about, if you guys, obviously you guys are very concerned about developing software and legacy code, and I feel like one of the key aspects that saves our code from being unmaintainable, hard to work with, is the ability to have good unit tests around our code. So I consider test-driven development and test-first development, as I think of it, as really a foundational practice. But I'm sad to see that when I look at how people are doing these practices, they're not doing them exactly well. They're doing them in a way, actually, that prevents them from getting the benefit. So to me, one of the main benefits of doing test-first development, well, I think that the very biggest benefit is really that it helps us understand requirements, helps us build testable code, and helps us in the design process, because it gives us another perspective, the perspective of our tests, which is really the perspective of our callers. And that helps us understand and how to build better code. And all that is really, really important. But there's also another aspect of TDD, which is that it helps us regress, that it gives us the ability to regress our code and automate this sort of process of validating that our code still works. It's a, big, hard process. And we in the software development community, our job is to automate other things, like automate other industries. So we really would like to automate our own industry as well. We should take our own advice. And so instead of manually doing these tests, we can automate them with good unit tests. But the problem that I see people doing is that they write too many tests, and they write implementation dependent tests. And this means that when they go to refactor their code, a lot of tests break. And, one of the main benefits of doing TDD is giving us the freedom to be able to make choices, make design decisions late in the development cycle. This is really the dream of Agile. Agile is all about, being agile, being able to be flexible. And so oftentimes we know much more about a project towards the end of the project than in the beginning, and we're able to come up with better designs. So the ability to change our designs and refactor our code is absolutely critical. It's a very important aspect of development that I find very many developers completely ignore. And one of the ways that we are preventing ourselves from allowing ourselves to refactor code is actually by doing TDD. I would say probably more teams doing it incorrectly than are doing it correctly. They write implementation dependent tests so that when they refactor their code, the tests break. And instead of being there to support us and help us refactor our code, they actually become a larger burden than the refactoring of the code itself. And so people are scared to touch code and touch tests, and so they don't. It's like the way I think of it is these XP practices are like good medicine, and medicine will cure you, will save your life. But if you do it wrong, if you take it incorrectly, if you don't follow the directions, if you don't do it right, then boom, it can kill you, right? And so this is not uncommon for power tools. These are powerful concepts, and we have to understand how to wield them correctly. So there's this huge movement out there. It's called the TDD is dead movement. You probably heard of this. Nicholas is smiling. This when was it, like 4 or 5 years ago? And I think I'm not going to name any names, but these are pretty well-known developers within the community, and I understand their perspective, and I in fact agree with their perspective. They talk about things like test-driven damage, and I've seen this. I've seen people do TDD wrong, and it becomes a major burden. But that is not the fault of TDD, and that's really what I'm here to tell you today. I want to share with you that, if we do it correctly, and I've seen it done correctly many times, and I've helped thousands of developers do it correctly, and it's transformed not only their careers, but their companies, the business and the products they're developing. So I know it can work. It's just a matter of understanding and thinking about it in the correct way. And really, that's what I want to talk to you about today. There are several elements to really making TDD effective. This is an advanced practice, but I think the key element, the most important thing, is really thinking about it correctly. And what I see is most people think about it incorrectly. They think about it as a testing methodology. And who can blame them, right? Because TDD, test-driven development, it has the word test right there. But I'm telling you, it's not about testing. It's about something else. The way I think of it, and the bottom line is, I think of doing TDD as a way of articulating behavior. And Nicholas said it in his introduction, and I think it was just totally apt and exactly correct. Thinking about doing TDD in a way that is effective, that gives us traction, so that we can make last-minute changes. Cool. This is what you see here on the screen is a little diagram of my classes. It's just 18 things that I cover in my classes. Sometimes people ask me, is this a religious diagram? And no, it's not. It's an old technique in learning where if you associate concepts with geometric shapes, it becomes more memorable. So that's essentially what I did. I've taken 18 key concepts that I cover in the classes and put it out here. Some of them are principles, like OCP is the open-close principle. If you're familiar with that, I think about guiding light for us software developers. I'm always blown away that the majority of senior developers I know cannot name one principle in software development, which is interesting. Some of them are practices like integrate continuously or build in sprints. Others are disciplines like writing the test first or refactoring. Around all of these things are 6 key code qualities that I think are quite foundational to good code. They are things like cohesive, non-redundant, encapsulated, etc. These are all important concepts, but the reason that I'm showing this to you is that I want to point out to you that there's a finite list. There's not that many things here. There's 18 things together with about a dozen design patterns. When you understand those things well, I find that developers can completely transform the way they do their work. And life becomes a lot more fun because we don't get caught up in the pain of dealing with legacy code and all that stuff, because things get a lot clearer. We start to see cause and effect. And so we understand now how to make our code more maintainable and able to make last-minute changes. So that's coming up. Sorry, this is my short little sales pitch. And I'll tell you more at the end of my talk, but I just wanted you to know that I am coming up with a software developer essentials class. And this class is a 40-hour intensive. It's over 10 sessions. So it's 4-hour sessions that are very digestible. And they cover the XP practices, agile development. I try to fill in the gaps that all of us have as software developers because we've all arrived here from different means. And unfortunately, schools, at least schools in the US, they don't really cover these concepts very well, if at all. So it's really what I've learned from working with 10,000 software developers in my 30-year career as a trainer and developer, and modeling the top developers. And what I've discovered is if we think the way they think, if we do the practices that they do, we can get their results. And so I've seen lots of people go from 1x to 10x to even sometimes 100x in terms of productivity. It really is possible. And when teams do it, the entire team does it, and you can see amazing things happening. Anyway, that's the class. I'll tell you more about it at the end, and I'll give you the coupon code. But let's dive into TDD, which I think is one of the most valuable practices. Okay. This is me, and you know who I am. I trained over 10,000 professional software developers in my career, which I think is a world's record. I wrote a book called Beyond Legacy Code that Nicholas mentioned, and I'm super happy that it has been really well received in the industry. I wanted to give something back to the industry after 30 years, and I also wanted to make it so that managers could understand, because I find that that's oftentimes a limiting factor. Is we say to our managers or our bosses, we want to refactor our code, and they are like, why? We don't want to do that. We want features. And of course, we all want features, but we also want them to work well, and we want them to integrate well. And that oftentimes requires a little care and maintenance, just like everything else in the physical world, right? You wouldn't buy a Ferrari car and say, well, I spent so much money on it, I'm never going to, maintain it, never going to put oil in it because I spent so much money on it. Your car is not going to last very long, and everybody knows that. The same thing is true with software, but people apparently don't know that, which is interesting. The other thing about this slide I just want to mention is this is how you can get in touch with me. My website is called To Be Agile, and you can contact me there. And in fact, if you want to schedule an appointment with me, we can talk for an hour, no charge. And I'd love to chat with you about anything, really. If you got stuff about legacy code or ideas, feel free to look me up. I'm actually taking most of the month off, so I'll be around. And this is my book. Again, Beyond Legacy Code is really about how not to get there in the first place. So what I find is that before we can have a really deep discussion about how to fix legacy code, we have to understand what the something better is that we want to transform it to. We can't just transform it. We got to understand what good code is. And interestingly enough, I find most developers really don't understand that, what really good code is. So we spend, just like in the class, this book spends a lot of time focusing on what good code is about. And then towards the end, we talk about how do we put it all together, and how do we take those same techniques and apply it to legacy code. And most of the talk on legacy code, well, I wouldn't say most, but some of it really is focused on rationalizing why you would want to refactor code so that you can tell your manager. Because when I ask developers what the number one reason why don't you clean up your code, they say my manager won't let me. And so having compelling arguments for management is really important. This is part of our job, is to, we're the experts in this field, so we have to educate the rest of the people. So this is readable by a developer, but also readable by a non-developer, because they also are on our team and they also have to understand these technical practices. So it's not really how to do it. That's in the class. What this book is about is why to do it. So there's lots of how-to books out in the world. This is a why-to book. That's what I call it. Why are we doing the practices? And again, understanding them is really one of the key aspects of doing them well. Okay, and these are the 9 practices from my book. I'm only going to focus with you on these 2. Writing the test first and thinking about TDD in a specific way, which is specifying behaviors through tests. We just don't have time to go over the rest of them, but they're in the book. Okay, so let's talk about TDD. So people say to me, well, we do test-driven development. We write our tests after we write our code. Now, that to me is not test-driven development. Test-driven development to me is test-first development. Some people say I write all my tests first. and then I write my code. And that to me is still not test first development, because it's really the switching of perspectives between your tests and your code that gives you the insights. And if you're doing test last, as I call it, I think you can only get bad news. Either you know that your code works because you wrote your test and it passes. Oh, gee, well, I already knew that. Or something failed, and that's not fun either. But when you're doing, and very often what I find is when I do test last, or when other developers do test last as well, we find that we're writing our code that's not really easily testable. So when we go to write our tests afterwards, we have to rewrite the code to make it more testable. When you write the test first, you don't have that problem because you're always writing testable code. Sometimes developers and managers especially ask me, well, how can it be faster? I mean, you're writing a test for every one of your public accessible methods. So does that mean that you're writing twice as much code? And I say, no, it doesn't. Because to fully exercise your code, you probably need to write 3 or 4 times as much test code. And then they really get like, whoa. But there's a false assumption going on here, which is that the limiting factor in software development is typing. And I think we'd all agree that that's not true. What is the limiting factor in software development? Well, I find that there's 2 main places that we spend a lot of time when we're doing development. One is in reading and interpreting requirements. And according to an NIST study, it's almost half of our effort, and almost half of our defects come from poorly conceived of requirements or misinterpreted requirements. And the other thing, and of course, we don't love doing that. And the other thing that we don't love doing is debugging. And that's really where we spend a lot of time. I spend so little time in the debugger now. I used to be an expert at the debugger, and I actually forgot how to use it because I'm never in it anymore. My tests catch my defects before they actually can manifest, and I don't even notice it. I mean, it took me 3 seconds to deal with it. But if it sat in a queue for a while and quality assurance came back to me 3 weeks later, it might take me a couple of hours to get back up to speed and figure out what the problem was. So I find that it's far more effective to do TDD in this way. And also, by the way, that level of feedback, that instant feedback, is the thing that really makes it so that we understand, that we make that connection. If Pavlov rang the bell and then an hour later he fed the dogs, they would never make the association. It's the recency that makes the association. And the same thing is true with us. If I make a defect, if I do a bad practice as a developer, and 3 weeks later, QA comes to me and says, oh, you got to fix this, I never make the connection. But if I do something and instantly the computer comes back to me and says, oh, that's a problem, then I make the connection. It's even subconscious, but I make that connection and I don't do it again. So that's, I think, really powerful. And we talk a lot about feedback in Agile, customer feedback and all sorts of different kinds of feedback. The most powerful feedback you get is from your tests. That's the real feedback, because that really tells you how to build software well. And we can actually use it. When I look at the server logs from my heroes, the people who I model as like the great developers, people like Arlo Belshi and Llewellyn Falco, these are amazing, brilliant developers. And when I look at their server logs, they run their tests on average 3 times a minute, every 20 seconds. Think of how powerful you could be with that level of feedback coming at you all the time. So, leveraging the tools is a real key to success, I think. But the other thing is that we stop doing a lot of things when we're doing TDD. A lot of practices that are not as fun for us because they're not as productive. So this also helps us get better. So, for example, we don't have to spend a lot of time reading and interpreting requirements because our tests become the articulation of how to call our methods, what the parameters should be, what they should get back in return, what the completion criteria is. All those critical things are embodied in our tests. And as I just mentioned, we spend far less time in the debugger as well. So when developers realize that doing these XP practices like test first development is really about doing the things that we developers love to do, which is writing code. and minimally doing the things that we don't love to do, like debugging and reading requirements and attending meetings and all those things, then developers get really on board with doing XP. Because XP is not only more effective, but is more fun. So it might feel a little weird at first, writing the test first, because we weren't taught to do that. When I see developers going into lab for the first time, doing test first development, and they're all bought into it, and they're like, okay, I'm going to write the test first. So they do that. They intend to do that, and their hands start typing, and what they type is code. And they're like, stop it. And I had this experience myself. It's a habit that we have to break, because we just are in the habit of diving into implementation. But think about it. Everything else in life is not that way. If the idea is plan, do, review, right? That ready, aim, fire. It's not fire, aim, ready, right? It's not just jump in and do stuff and then figure out what you're going to do. It's have a plan, have an idea of what you're going to do, and then go in and do it. That's the effective way to do things. And that's what TDD really does, is the test memorializes your intent to create what you want to create. But it is slow at first, but there's a learning curve for everything. But if you want to gain exponential growth, you have to suffer that initial start. So look at the difference between linear growth and exponential growth. And notice that exponential growth does not beat linear growth until halfway through the chart. So that's the slow start. But then it goes much, much faster. So that's really the fast path, is the exponential. But if we want to take that fast path, we have to be willing to do that setup, suffer that initial slowdown to get things set up correctly, or that initial learning curve. Some of the benefits of doing TDD, not only does it give us a full set of regression tests, and I think of that kind of as the booby prize, because there are so many other benefits of doing TDD. It helps us sort of separate out tasks in ways that are manageable and understandable. It helps us break down big tasks into smaller tasks. It helps us create testable code. And that's really critical, because testable code is really code that exhibits a lot of good qualities, that is refactorable, that is straightforward to work with. Okay. So why does TDD work? Because it helps us focus on the right things at the right time. I hesitate to call it a process. I called it a formula in my book as opposed to a recipe. Software development, because it's not like you have to follow these steps. It's not a set of rules. I think Waterfall tried to make it that way, and that's not very helpful. Agile is all about becoming present, not following a plan, but rather being aware so that you can be flexible. And so TDD helps us with that. It helps us understand problems more deeply when we do it well. But I've seen TDD fail. In fact, I've seen it fail more frequently than I've seen it succeed. One of my clients said to me, we had to abandon TDD. We tried it for a while, and we realized that it would take a day to refactor our code and about a week to refactor our tests. And we had the choice of either going out of business and doing TDD, or abandoning TDD and staying in business. Well, if you're ever in that situation, please abandon TDD. But again, it's not the fault of TDD. It's really just how they were practicing it. See, they bought into the whole idea of clean code. They understood that their code should be cohesive and loosely coupled and encapsulated and non-redundant and assertive and all those good things. But what they didn't see was that their tests were first-class citizen code as well. And so while their code was really clean, their tests were a mess. I actually spend more time refactoring my tests than I spend refactoring my code, but it's worth it because my tests give me so much value. Another client said to me, well, it takes too long to run our tests. It can take hours, so we don't run them very often. I said, well, why? Why does it take so long? He said, well, we got to get a handle to the database. And then I'm like, whoa, wait a minute. Why are you accessing the database? You're not Oracle. They're across the street. Why are you testing Oracle's code? They're like, well, we're using the database. And I'm like, no. I taught them a whole bunch of techniques for mocking and shunting and endo testing and all sorts of other techniques to make untestable code testable, and then their tests ran fast. And you can run hundreds, thousands, even more tests that quick if you write them well, if you write them to only test what needs to be tested. And you probably have code coverage standards. Typically, when I talk to companies, they have 70, 80% code coverage standards. I'm not a big believer in that, because what I find is that developers will cover the easy code, like the getters and setters, and leave the real gnarly code that's really hard to test uncovered in that 20% that they don't need to cover. And that's exactly the wrong thing to do. So if you were to make a code coverage standard, I would suggest making it a function of cyclomatic complexity, which, if you're not familiar with the term, you can look it up. It's just the number of paths through your code. So if you have a cyclomatic complexity of over 1.8, then you have to have it covered. And if it's simple code, then you probably don't need to. My own personal view is I always strive for 100% code coverage. And if you always write the test first, you'll always have 100% code coverage. With some minor exceptions, sometimes you got to make external calls and you lose 1 or 2%. Please don't sweat that. There's nothing in that 1% of code that's not covered that could go wrong anyway. So don't get obsessed with the number. The idea is that we want to make our code, so that it's covered. But code coverage does not mean that it's bug-free. It just means that you've exercised the path. And that's just one step towards making defect-free code. Okay, good. So we want our tests to run fast. If we looked at code coverage tools, if code coverage tools told us really the amount of code coverage, instead of seeing 70 or 80% coverage in code, we'd see more like 700 or 1,000% code coverage. Because what I notice is developers write the same test over and over again to exercise the same code over and over and over again. And you don't need to do that. You only need to write one test for something. Okay. So again, TDD is not about, and this is really important, it's not about making developers do QA. We're not trying to, what is it, the expression, feed two birds with one scone, I think is how it goes. We're trying, QA is still important, and depending upon the kind of application you're working in, QA can be critical. If you're doing, business critical or mission critical applications, you definitely need a strong QA, because what QA is about is thinking about what could go wrong. And what TDD is about is thinking about what could go right. And that's a really key distinction. We don't want to put our QA hats on when we're doing TDD, because then it gets overwhelming. What we do want to do is write just the bare minimum tests when we're doing TDD for our happy paths, and also our unhappy paths, but not trying to sabotage the system or trying to think about all the things that could go wrong, because it would overwhelm us. That's what QA's job is. And there's a good analogy to this, which is if you've ever done any writing, everybody's taken an English composition course in high school, and they always say to you, don't edit yourself when you're writing. When you're writing, just spew, just let it all come out, and then later go back and edit yourself. And in fact, there's jobs in the field of writing that is all about that. They're called editors, and there's many different kinds: developmental editors and copyright editors, and all the different kinds of roles there. And it's very different from being an author. So when you're editing, you're really doing QA. And when you're authoring, you're really doing development. So TDD is about authoring. It's about finding the right way to articulate the behavior we want to create. Good, but it doesn't replace QA. It does simplify their lives, though, very often. So what's a test? If we looked up on answers.com or the dictionary, we would find a definition that it's a critical means of evaluation or a trial or something like that. But the word test in test-driven development doesn't mean that. It's actually not a test. How could it be a test? Because there's nothing to test if you write it first, right? So what is it? I think of it as a hypothesis, as a proposing something that is not yet there. So, and then the code becomes the experiment to prove or disprove the hypothesis, basically. So a test, we want to test, we want our test to test are behavior, but what tests are tests? And there's a couple of things that test our tests. One thing is the behavior itself, so they sort of cross-check each other. And the other thing is that when we're writing our tests, we make it fail first, and we'll talk a bit about that in a moment. But that also validates and tests our tests. So it really has two roles. It becomes a test once I implement it, once I write the code to make the test pass. And then it is truly a test. And they're available for me to regress at any time. So there's really two roles that TDD plays. One, to assert a hypothesis, and two, to validate my code, to validate that it still works as expected. I find that there are three critical factors we need to do in order to really understand and be effective with TDD. And I tried to remove some of these factors because, I want to make it so that I can do it effectively. But I found that I have to have all three of these things in order for people to assimilate TDD. Number one, they have to understand what it is. And that's really what we're talking about here. Thinking about it as a form of specifying behavior rather than verifying behavior. Number two, they have to have a bunch of techniques for making untestable code testable. And that's really important because most of the code written today is untestable code. So we need a whole variety of techniques like mocking, which most developers are familiar with, but a whole other set of techniques that I find most developers are not familiar with, like shunting and endo testing. And these are really helpful, really useful techniques. And then the third thing, and this is the critical thing, is we have to experience it. We have to actually physically do it. Because, you can talk about it forever, but until you actually see your test catch a defect and feel that feeling of elation, then you won't really get TDD. But once you have that experience, you will. So I find those are the three critical factors in doing TDD effectively. And that's why I structured my class the way I did, where we have hands-on, where we do, 12 to 16 hours worth of development, and we're building a full real application, none of these toy projects. So that when you finish, you're like, okay, I can handle anything, which is good. So I want to give you just a couple of metaphors for doing TDD. One comes from Kent Beck's excellent book, Test-Driven Development by Example. This is the first book written on TDD, and it's still, I think, the best book on TDD. I reread it. Every time I reread it, I find new things in it. Unfortunately, there are not many other good books on TDD. We really need at least a dozen great books on TDD. And we only have Kent's book right now. But I have a couple of friends who are writing some books on TDD. Hopefully they'll come out at some point soon. Kent's metaphor is if you take the ratchets on if you want to get water from a well, like imagine we live in a village and we get our water from a well. And this is a traditional deep well where there's a bucket on the end of a chain, and we throw the bucket down into the well and it fills up, and then we crank it back up. If there are ratchets on the crank, then it goes, if there are no ratchets, first of all, when you go halfway up, if your arm gets tired, you let go and the bucket goes back down. But if there are ratchets on the crank, then it goes click, 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 click. And if you let go, it clicks in place. So Kent's metaphor is that we're always moving forward, never moving backward. I like that metaphor. And my metaphor for doing TDD is 20 Questions, the game, if you've ever played that as a child, where one person thinks of something and other people have to guess using yes-no questions. They ask questions that the person who's thinking of something can only answer yes or no. And the object of the game is to ask as few questions as possible to guess what the first person is thinking. I like that metaphor for TDD because really TDD is about articulating behavior with the fewest tests possible, but still articulating the behavior. That's the key. And when we can do that and get on the same page with that, boy, amazing things can happen. So I want to just give you a very quick introduction to TDD and talk about some aspects of it with you in the 15 or so minutes that I have left. So there are 3 steps. Write a failing test, make the test pass, and then refactor for quality. And we oftentimes assign colors to this because this is the visual feedback that we get. So writing a failing test means that we call it the red bar because we get a red bar. When we make the test pass, we get the green bar. And then there is no visual feedback for the refactoring step, but I like to think of it as making our code golden. So I use the gold bar. So we go between red bar and green bar. There's this cadence that we follow in TDD, and it kind of sounds kind of like repetitive when we talk about it, like it's kind of this boring thing, but it's not. It's actually provides a context for all the development, just like the beat of a drum provides the context for the rest of the song. So it sort of is the through line for doing development, which is very nice. We start by writing a failing test. And one of the misnomers in doing TDD is that it's not about getting to green bar. TDD is about turning the red bar green. And the key distinction here is that we have to first have the red bar. So always start by writing a failing test. Sometimes it seems like busy work at first because I don't have any implementation at all, so I know it's going to fail. But seeing it fail is the proof to you that it can fail. And you don't want to write a test that can't fail, because a test that can't fail is worse than no test at all. It's a lie. We don't want to put lies in our code. So write a failing test and see it fail. And the 1 out of 100 times that you don't see it fail, that it actually turns green, it means that somebody else wrote that implementation for you. You don't have to do it. So that's a good thing. So always start by writing a failing test. And then celebrate. I wrote a blog post, and by the way, you'll find hundreds of posts on all this, on the XP practices on my blog at tobeagile.com. And it was a while ago that I wrote this blog post called Celebrate the Red Bar, because I realized that maybe close to half of everything we need to do is done when we're at red bar. I mean, we understand what we're trying to do. We understand how we want to call the method that we're creating, what his parameter should be, what his return value should be, when we will be done. We've made enormous progress. So celebrate, like, hey, recognize that we've made a lot of progress so far. And then I like having the red bar, but once I'm there, I want to get to the green bar as quickly as possible. So what I do sometimes is even forsake some of the code qualities that we've been talking about, because I want to get to the green bar as quickly as I can. And I made a promise with myself, which is once I get there, I will go back and atone. I will clean up my tests. I will clean up my code. I will use good intention revealing names. I will make the algorithm more readable, just so that I can, get it working. So that's the refactoring step. So getting to the green bar is typically pretty easy, but staying in the green bar can be challenging. And I think it was Kermit the Frog who said it best when he said, it's not easy being green. So being green is really about refactoring. And by the way, remember the refactoring step here in TDD is built in. So we're always refactoring in the small. It doesn't mean that sometimes we don't have to refactor in the large as well. But at least we get to, before we send to production our API, we get to clean that API up and make sure it's supportable and maintainable. So that's the refactor codes step. And in addition to refactoring our code, we also want to refactor our tests, because our tests are also first-class citizens in code and important. So how many tests are enough? Like I told you, I strive for 100% code coverage, because I always write the test first. I always get 100% code coverage. So on to 3 steps. Is red bar, thinking about what we want to do. Green bar, actually getting the implementation working, and then gold or refactor to make it supportable. And the supportability step is critically important. Every other form of engineering has productization or supportability built into it, and we don't in software. Which is why, by the way, it costs 5 times more to maintain code out in the field than it costs to originally write it. There's not a lot of statistics that have been done on our industry, but this is an NIST study, which I quote in my book, and I'm shocked by that. So when your manager says to you, well, it's pretty expensive for you to build this feature, you can say, if the feature is actually in the field, it's going to cost a lot more than how much it costs to build it, like 5 times more. So what we're trying to do is reduce that cost. So let's take a quick example in the 11 minutes I have. Suppose I want to write an adder class. And I know that every language supports addition, but maybe I want to write an adder class just for whatever reason. So I'm going to start by writing a failing test. My test is going to have the code in here that says new adder. So I'm going to create a new adder, and then I'm going to assert that when I call the add method with the parameters 1 and 1, it's going to return the value 2. Basically, that's what this assert is saying. And when I run this test, what happens? Well, I don't have the implementation yet. So, oh, in addition to what I do is I can't run the test actually because I don't actually have any implementation at all. So what I'll see is in IntelliSense, it'll put a little red squiggle underneath the new adder. And if I dally my mouse over, it'll say, I don't see an adder class. Do you want me to create it? And you say yes. And then it puts a squiggle under the add method. It says, I see the adder class, but I don't see an add method there. Would you like me to create it? And you say yes. And it creates a stub for you that looks like this. And it just returns 0. So of course, it's not going to return the product, the result of 1 and 1. So the end result, what I'm going to do when I run this test is I'm going to get the red bar. It's going to fail. But I tolerate it because that's my intention. I got the red bar and that's my goal. Which gets me excited for about a moment and then I'm bored again. So then I want to get to the green bar. So what's the fastest way I can get to the green bar? And when I ask developers this question, they immediately say what you are thinking right now, which is return the hard-coded number 2, right? It's the very fastest way to get there. So that's what I'm going to do. I'm going to return the hard-coded number 2. And when I run my test, what happens? Green bar. Hey, I am on a roll now. Okay. And if I only want to add the numbers 1 and 1 together, then I'm done. But that would be a pretty poor adder. So I probably want to come up with another use case or test case. And so I'm going to assert that when I pass in the numbers 2 and 2, I get back the number 4. And when I run my test, what happens? Once again, I get the red bar. Why? Because it always returns the number 2, and sometimes I want to return the number 4. Okay. So now I have a choice. I can either say, if parameter 1 is 1 and parameter 2 is 1, then return 2. If parameter 1 is 2 and parameter 2 is 2, then return 4. Or I could simply return parameter 1 plus parameter 2. Now, this is showing us something actually kind of interesting and important, which is that when we're doing TDD in this way, it tells us when to do the real implementation. See, one of the things that is effective is to fake it till you make it when you're doing TDD. But when should you stop faking it? And the answer is when it's harder to fake it than to do the real implementation. And as you can see, it's a lot harder to type in those 2 conditional statements than to just return P1 plus P2. So this is telling us when to do the real implementation, which I think is good. And notice how doing the right thing is also doing the easiest thing. And we want to set things up to do that in software development because we're human and humans will always try to do the easiest thing. So we want to create the context for software development where doing the easy thing is also doing the right thing. You may ask, how do we do that? Value testability. That's the bottom line. If you value testability, if you make that your one metric for good code, testable code. And I mean, I say this, I'm throwing around these words, but I realize that most of us don't even know what these words mean. Misco Havery, another one of my heroes and brilliant developer, the author of Angular, says that he rarely meets a developer who knows how to write a good test. And honestly, that's true for me as well. I mean, you can write a test, everyone can write a test, but is it a good test? And we'll talk about what a good test is in a few moments. Okay, and so we get the green bar, and we're back to the green bar. So this is one aspect of using TDD as a form of design, helping us do design in the right sequence. There still is a sequence, even though we're sort of doing development, it's more of an art than a science, but there's still a sequence involved. So Uncle Bob has 3 laws of TDD. Bob Martin, you probably might have heard it, and I think it's something along the lines of you're not allowed to write any more implementation than to make a failing test pass. You're not allowed to write any more of a test than to make the test fail, and compilation failures are considered failures. And then you're not allowed to write any more production code than is sufficient to make that one failing test pass. In other words, just one little thing at a time, basically. I also have 3 criteria for what a good test is. A good test to me, it always fails for the reason that you intended it to, never fails for any other reason, and there should be no test in the system that fails for the same reason. In other words, our test should be unique. Easier said than done most of the time, but really, really important. So some characteristics of a good test: it runs fast, has a quick setup and teardown, tests only one thing, is small so that if it fails, we know exactly the one thing that it failed for, right? Um, uh, those kinds of things. Pretty straightforward. It is completely independent of all the other tests in the system. So we said that a test is not a test, and a unit is not a unit as well. And this is I find a real key misunderstanding in developers. People think that a unit is a unit of code. So they argue whether it should be a line of code or a method or a class. And I know lots and lots of developers who absolutely insist that every single one of your methods, production methods, should have a test method. Every single one of your classes should have a test class. This is not true. Do not do this, because if you do this, you're writing implementation dependent tests. And then when you refactor your code, what do? There's more classes. Do you write more tests? You can't even do that. That wasn't the intention. We want to write tests around behavior. So the word unit was adopted to represent an independent unit of behavior. And so TDD is about writing tests against behaviors, not against implementations of behaviors. Not how we do it, but what we're doing. So we're leaving some things out. We're leaving the implementation details out of our tests, which gives us the freedom later to change those implementation details, and our tests are still supporting us. And that is really the process of refactoring. So writing good tests support us in refactoring our code. And when I talk about test semantics, what I'm really talking about is how do we articulate behavior in code for the code that we want to build through our assertions. And when we understand how to do that and all get on the same page with that, then life becomes way more understandable. Suddenly communication gets much higher fidelity between developers because we're all on the same page. And it all comes from understanding how to articulate behavior through tests. One of my goals in the TDD class that I teach is that we would all leave the class knowing how to articulate any kind of behavior. So I could give you any kind of feature, and you know exactly the right number and kind of test to write to elicit that behavior. That's a very powerful way of doing software development. I know teams that can just do amazing things with those ideas. I want to share with you in the brief amount of time that I have left. Nicholas, can I go over just a little bit? Would that be okay? You can nod.
Yeah, sure. No hard feelings. Don't worry.
Thank you. I hope this is of value to you that we can cover this. There's a technique called instrumentation, and I find it's incredibly valuable for helping your tests appear to be or work as specifications, helping them read as specifications. So instead of doing something like this, so here I have a test class. The method is called test constructor, which is not a good name because it's really not really testing a piece of code. And then I create a new user with a first name, last name, email, username, and password. And then I assert each one of those fields are correct. And notice the redundancy in this code. And this is the worst kind of redundancy because it's in strings and the compiler can't reach into strings. So if I misspelled his first name, Clark or something, when I do the assert, then the compiler can't even tell me that there's a problem, but I'll just see the assert fail. And I have to spend time figuring that out. So instead of doing something like this, do this. First, I give it a good intention revealing name, like test retrieving parameters after construction. And then I create fields for each one of those different values, like first name, last name. Now, when I look at my new user call, I can easily read what those fields are. And it makes sense. It's readable like a specification. And if I misspell the first name from the passing into the new user to the assert, then the compiler can tell me that I misspelled it. So this is a little technique called instrumentation, and I use it all the time. It allows me to let my tests read more like a specification. You can also make generalizations more clear. So instead of testing 1 and 1 equals 2, I just specify variables for any int as 1, and the result is 2. And now my assert reads assert equals the result when I add any int and any int together. So it's just more readable that way. Some benefits of doing instrumentation: it allows you to really understand and read code more like a specification. That's really the main benefit. I want to go, because I know I'm at time, I want to go a little quicker with you. So to define how many assertions do I need to define a linear range, like a range from 1 to 10? And I want to specify, like, maybe there's 3 or 4. So there's the minimum value. The minimum value -1 is the first test that I would write. It is probably going to throw an exception because it's out of range. Then there's the first valid value, which notice I make on the boundary. So it's not any value within the range of 1 to 10, it's 1, because that's the first valid value. And that assert should pass. I'm going to skip the third one for a moment and go to the fourth one. And the fourth one is maximum value +1. That tells you and tells me that we're over the boundary. And again, we'd probably throw in an exception, maybe a different exception in this case. But is the third assert superfluous? And I personally believe it is, because it passes and fails for the same reason that the second assertion does. However, a lot of people disagree with me. They would rather have that fourth assertion there just for symmetry's sake. And if you're in that camp, if you believe that, I will not argue with you at all. In fact, I will praise you for having any test at all in your code. Good. Very good. I also, and I don't see anyone doing this as well, which is I have asserts for my constants. Because anything that could change, if you could change anything in your code that would change the behavior of your system, I want to test to fail. So I have just somewhere off to the side asserts for the minimum value, maximum value, or all the other constants that I have. So if somebody changes it, boom, that test will fail. There are 2 kinds of tests. We call them workflow tests and boundary tests. We've been talking about boundary testing, which is validating values for parameters, return values, things like that. But there's also workflow tests, which tests a workflow, a sequence of events. And we do this through mocking using test doubles. Okay. And we're not talking about that today. So bottom line, write testable code. And please don't test into a board. You'll find that if you test into a board, you're not going to get the main benefits of doing TDD. Ken Beck is another one of my heroes, and he came up with all these ideas, and he's incredibly brilliant. But this one piece of advice, I think, is not the best piece of advice from him. So in other words, instead of testing into a board, think of your tests as a form of articulating behavior, as a form of specification, and then you'll get really, really good at doing TDD. And even though TDD is so amazing, TDD is not enough. And that's why I spend time really focusing in the class on design issues, on other kinds of development issues, on requirement issues, all sorts of other kinds of issues, so that when they all come together, we can do amazing work. All right. So we've just scratched the surface. I want to give you some resources to draw on. I mentioned my blog. I'm in my 12th year of my blog. I also have a monthly newsletter for free, so you can sign up there and follow me on Twitter. Of course, I have a book, and please feel free to check it out if you like. And also, I have the class coming up. It's the Certified Scrum Developer class. In addition to covering all the XP practices, you also get a Scrum Developer certification. And we talk about all these practices, TDD, refactoring, emergent design. It starts on January 11th. And as Nicholas said, you can get a 25% discount with the discount code Socrates. So you can go to my website, tobeagile.com, to learn more, or go to the link there to directly register. I don't think we have time for Q&A, but if we do, I will hang around if you have questions.
Yeah, we don't have much time, but I encourage people to follow up on Twitter.
Yes, please.
Let me just check quickly. Oh, this one is very quick. How long is your upper bound for the duration of running a test suite?
Oh, that's a great question. So there's really 2 answers to this, because whether we're talking about, you said test suite, so I'm assuming that's happening on the main server. But I also want to run my tests on my local machine as well. And the local machine should run faster because I'm only testing the stuff that is involved in what I'm currently working on, whereas the nightly build or whatever is building everything. So Jim Shore, in his book, The Art of Agile Software Development, says that you should your build should run for no more than 10 minutes. That is way too long to me. For me, my local build should run that quick. I want it run in a second or 2. because I want it to run all the time. The nightly build, depending upon your system, sometimes we have to build a whole system to do full regression, and usually that's put off into a nightly build, or I've seen even people putting it into the cloud and making thousands of servers run against it to make it run faster. So there's all sorts of techniques, but the bottom line is try to make it run as fast as possible because you want people to run it all the time.
Yeah. Well, I think also it's personal, but the key way to know if that's too slow is, do you feel that you don't test much often because it's too slow?
Yeah.
If you feel prevented from testing because it's gonna take me 1 minute or 10 seconds regardless, this is the moment where it's too slow for you.
Yeah.
All right. That was super great. Thank you, David, for sharing all of this.